And we're back with another great session. So we already touched a lot of topics now in the last couple of hours, lots of great content, and we will have another one for you. And this is Mark Hennings' session. It's about an introduction to fine-tuning large language models. So in this session, we're going to take a bit of a step back and get into the basics. So Mark, thank you for joining.
Hello. I'm excited
Hey.
to be here. Thanks for having me. Matt's
Yes.
session was awesome, but I'm a little nervous. I haven't prepared any superhero voices.
No?
Oh no.
Oh.
No, I'm joking. I feel like we've capitalized on that now. On to the next. You're doing an intro to something that's quite advanced, right?
Yeah.
So that's a real mix.
I'm gonna try to make it easy though, so
Love
don't
that.
worry.
That's
sounds
exactly
really
what we
good.
need.
Before you start, can you introduce yourself?
Yeah, my name is Mark Hennings. I'm a serial entrepreneur and I'm a founder at Entry Point AI, which I've been building since December. It's a platform for fine-tuning large language models. So I've been almost entirely focused on fine-tuning for the last year.
So,
Wow, so we are learning from the expert here.
really,
I mean,
yeah.
like literally from it all coming out. I saw something I think on social media recently where it was like, so when are we going to start asking for like 10 years worth of experience in generative AI? And it's like been a year, do you know what I mean? Of actual like not researchers kind of doing it. And so yeah, no, very interesting. So great to have you, Mark. Thank you for joining us.
Yes. Are you ready?
Let's do it.
Okay, the floor is yours.
Awesome. All right, so we're going to start with some background information um, to get rolling here. So what is fine-tuning? Fine-tuning is training a foundation model on additional data. So don't worry about the terminology too much. We might use the term training, fine-tuning, learning. In the scientific papers, they call it adaptation. It's all kind of the same thing. So we're going to teach our foundation model to be better at different types of tasks. And that is fine tuning. We're going to bring our own data and then use that to teach it. So to understand fine tuning, first you have to understand how a large language model comes to exist. The way we get modern foundation models is with pre-training, and this is really expensive. It uses a vast amount of text. Like Llama 2 was trained on 2 trillion tokens of data, which is about 1.5 trillion 1.5 trillion words. So it uses thousands of GPUs and it's very expensive, and you can't do it very often. So we get these foundation models and then we try to get the most out of them in different ways. And that's really where fine tuning comes in. So the type of fine tuning that's talked about most often is instruct tuning, which is where we're taking this foundation model and we're teaching it to respond in a way that humans are comfortable with. So we're creating chat models, essentially. They're conversational. They interpret the things we say to them as requests. That's not the native behavior of a model when it's first pre-trained, which we'll look at in a minute. And from the instruct tuning, we go into safety tuning. Safety tuning is where we have this model that will respond to our instructions, but now we don't want it to respond to certain things because it might tell us something that's inappropriate or how to do something illegal or just say something that's bad for our brand in general. And from that safety model, or even one of the prior models, we can then fine tune on a very specific task. These are often called like downstream tasks. And what that means is that it's a subset of what you can do with the foundation model, but you want to make it really good at that task. So you can fine tune it for performance. There's also this experimental area, which is domain fine tuning. So let's say you have a foundation model that's kind of been trained on very general information, it knows English and other languages, but now you want to make it an expert in finance, medicine, or law. And so there's a lot of people experimenting with this and trying to see if they can beat benchmarks by doing domain tuning. So the point of this chart is to kind of show that there's a lot of different things you can do with fine tuning. And we're just doing a lot of it after we have a foundation model to get different variations of that model. And there's endless combinations of it too. Now to understand the effect of this instruct tuning, which is turning the foundation model into a chatbot, we can look at GPT-3. Now GPT-4 and 3.5 aren't really available in the foundation model format. So that's why we're using GPT-3. With Text DaVinci 003, which has been instruct tuned, you say, show me how to bake a cake, and it starts to list ingredients. Like it's trying to show me how to bake a cake. With the base model, before instruct tuning, you say the same prompt, and it sort of goes off on a weird tangent. Give me the skills I need and inspire me with the passion I need to be successful and healthy on my journey of food addiction through recovery. That's not telling me how to bake a cake. It's very strange. It's basically doing this kind of arbitrary autocomplete. So it's kind of amazing that we can turn this sort of random outputting model into something so useful through instruct tuning. But there's lots of other ways to fine tune your model. So in general, fine tuning shows large language models how we want it to apply knowledge. So in businesses, for like automation purposes, there's all kinds of ways to apply knowledge. Now, I really like to express this in concrete terms. So here are some different use cases. Maybe you can get one of these in your head as we continue the presentation of like a specialized task you might want to fine tune for. Writing reports, emails, articles, product descriptions, identifying spam, detecting fraud, extracting, normalizing, or enriching data, translating, paraphrasing, rewriting, qualifying a sales lead, ranking priority of support issues, flagging harmful or inappropriate content, and much more. Now let's talk about some characteristics of fine-tuning. First of all, it's a type of supervised learning. Again, don't get hung up on the terminology. This just means that we're giving it input-output pairs. When we do the pre-training of a model, it's just getting unstructured text and learning from that. In this case, with supervised learning, we're telling it what we think a good answer is or a good response is to the input. So we're showing it a correct answer. It's a type of transfer learning, which means that you're starting with a model that has already been trained, which we showed in the chart, and you can fine tune a model that has already been fine tuned. This can go through many different phases. And unlike pre-training, we've made fine tuning very, very accessible with parameter efficient fine tuning methods. QLoRa is a really good example, which allows fine tuning on consumer grade GPUs. So instead of having like thousands of these really, really expensive high performance GPUs with huge memory banks, like you can actually fine tune and get high quality results on much smaller machines. Fine tuning also limits the scope of what the model will do, which might sound like a bad thing, but I would say it's a feature, not a bug, because it increases the predictability of the model behavior. And another effect of that is that if you fine tune for one really specific task, it can degrade the performance for other tasks. So safety tuning, for example, while it's really important, it can also make the model not perform as well at some other things that were unintentional along the way. So this is basically taking a generalist model and turning it into a specialist that specializes in one thing. It can be really good at that one thing, but may not be good at other things, and that may actually also be a good thing. Fine-tuning misconceptions. There are a lot of misconceptions about fine-tuning that I think are helpful to try to clear up early on. One is that you're teaching a model facts. And while it's true that you can fine-tune a model and it may regurgitate some of the information that you taught it, right? That doesn't mean that it actually stored or knows those facts. It's sort of incidental in the process. It's not guaranteed. And so that's why retrieval augmented generation is a great way to actually bring really clear and discrete facts into the prompt. It's a really good use case for it. I'm really glad that Matt talked about that, so I don't have to go into it too much. We will cover it a bit here. There's a misconception that fine-tuning requires a really large data set, and I'm delighted to tell you that you can actually start with about 20 examples and start to see meaningful changes in model behavior. So that's something that you could even hand write or hand label in like an hour. It's too expensive. It's not true. Most of the fine-tuning jobs I run cost 20 cents to $1. It's too complicated. Maybe that was true. It's changing very quickly. It's one of the reasons I create Entry Point AI in order to make fine-tuning more accessible to everybody and remove a lot of the gotchas that can trip people up. And then there's a lot of articles that compare fine-tuning to retrieval augmented generation and sort of imply that you have to pick one. And they're actually completely complementary. So looking at 3 techniques in AI: prompt engineering. We'll look at prompt engineering, RAG, retrieval augmented generation, and fine tuning, and just do a quick comparison so we can see how they fit together. So prompt engineering is easy to work with. It's great for rapid prototyping. It's very intuitive because you can use these, human familiar instructions to the model. RAG is amazing because you can connect external data sources. You can insert dynamic knowledge into the prompt, and it can be real time. So like in Matt's examples, he was doing API calls and getting real-time information and inserting that into the prompt. Prompt engineering and RAG are both limited to the context window. So they do have to put the information in the prompt. With fine tuning, you're narrowing the model's behavior, you're getting more predictable outputs, and you're baking in the style, tone, and format. Prompt engineering and fine tuning both steer model behavior. RAG and fine tuning both allow you to apply data and domain knowledge to your particular task. But the thing they all have in common is they all lead to better outputs. So often with fine tuning, you're also using a prompt in it to steer the model. You're combining the two. Fine tuning and RAG work together because fine tuning uses prompts just like prompt engineering. So you can insert dynamic knowledge into a fine tuned model prompt. And we should be thinking of how to use these things together, not like which one do we need to choose and then forget the others. So it's all part of the journey. All right, so now that we've covered the background information you need to know, let's talk about really the benefits of fine tuning and when you should do it. So the benefits are that, first of all, I love this one, is that you can teach intuition where words fall short. And let's imagine that you are like the best journalist in the world. You have this amazing writing style that people love, and I'm an aspiring journalist, and I ask you like, hey, I want to be just like you. I want to do things exactly like you do. What are the 50 things I just need to know? And if I just do those 50 things, then I can be you, basically. It's like, even if you could come up with 50 things that describe best what you do, like, and I follow them, I'm not going to replicate like the way that you do things, because there's so much nuance that gets missed by moving into that like instruction-based format. So fine tuning actually allows us to show, not tell, and we can teach the model through example, and it learns the little patterns and the little things without having to explicitly state it. So I just think it's a really cool way to think about imitating behavior instead of having to everything be instruction-based. As we talked about, it bakes in the style, tone, and formatting to your outputs. This is really helpful when you combine with the predictability, because you can get more consistent type of outputs that you can actually use in your code. Fine-tuning narrows the range of possible outputs, which is very useful also with creating a natural resistance to prompt injection. So let's say, hopefully at the end, if there's time, we're gonna fine-tune a classifier that's a tweet sentiment classifier. And we take a tweet and we just say, is this positive or negative sentiment? Well, because we train it to just output positive or negative as the output, it's not going to go off the rails and tell us, how to do something illegal or repeat back what its prompt was, because it's been trained to output these specific things. So there's sort of a natural resistance there. You can also train smaller models to perform tasks cheaper and faster, which is really important because as models get bigger, they're also getting slower and they're getting more expensive. And so as we look at optimization, speed and cost are very important, especially at volume. And then I would argue that fine tuning is also a better workflow for teams because it provides us a layer of training data to work with, which I'll show you in a minute. And finally, fine tuning reserves your context window for the most relevant and dynamic content. And why is that important that we reserve the prompt? Can't we just throw everything we need in the prompt and just let the prompt get longer? There's this term called prompt stuffing. Well, the problem is that large language models lose focus when you give them too much. There was this interesting paper last month called Lost in the Middle. It's very timely with this 128,000 token context window from GPT-4, right? GPT-4 Turbo. But the paper shows this chart that as they increase the number of documents in the input context, the accuracy starts to go down. And it says that in particular, we observe that the performance is often highest when relevant information occurs at the beginning or end of the input context, and significantly degrades when models must access relevant information in the middle of long context, even for explicitly long context models. So what that means is that the models pay more attention to things at the beginning or the end, and can often lose sight of stuff in the middle. So you don't get a linear benefit from just including more information and throwing it all in the prompt. Not to mention that makes it more expensive to have more prompt tokens. So when we're talking about actually applying fine tuning, there's really two strategies I'd focus on. The first one is quality above all else, where you're going to take the largest possible foundation model and you're going to aim for the best possible output. And you're just going to train it on your data to make it better at that particular task. The second is to optimize for speed and cost. This is where you're selecting a smaller model and then training it to perform at a higher level. Optimizing for speed. I apologize in advance. I don't have GPT-4 Turbo, but my GPT-4 example should be pretty timeless because in general, larger models are going to require more compute. They're going to be slower because they have more parameters. But here we have GPT-4 versus GPT 3.5 with 10 tokens. You can get an output 3 times faster with a smaller model. For 1 million requests on GPT-4 versus GPT 3.5 fine-tuned, you can save 89% on cost. And then some of this cost savings comes from reducing the prompt length. So here on the left, we have an engineered prompt, which is saying how to write a blog post on this topic, and then how to do it. With a fine-tuned model, because you've already trained it on examples of your blog posts for different topics, you could theoretically reduce it by 90% to just the piece of dynamic information that's changing from prompt to prompt. So you're eliminating a lot of the boilerplate because you taught it implicitly how to do the task. And then in terms of team workflow, if you have one epic prompt that your entire feature is sort of predicated on, it gets really dicey to just have people pushing changes to it, especially when you consider that even the order of like what's going to be at the beginning or the end could have this outsized impact on the actual end performance. It's also just sort of like having your entire Git repository for a project be one text file. So with fine tuning, you have this layer of training data that's completely scalable. So when you want to cover edge cases or add functionality or behavior, you can add training examples, or you can modify your training examples and improve the quality of that training data. So different people could be working on different subsections of your training data set that corresponds to different behavior that your model is supposed to have. All right, so now we have, this is actually part 3, hyperparameters and evaluation. So I really want to actually teach people how to fine tune, not just to have this theoretical knowledge about it. So when you're going to start fine tuning, and I hope you do, here's a few things that'll help you be less confused out of the gate. Hyperparameters are just settings, all right? I think they added hyper in front of it because parameters is already used to describe the weights or the numbers, the values in a model, but don't let it throw you off. So the most common hyperparameter that you'll see is number of epochs. And this is the number of repetitions that the algorithm is going to use to go through your training data set. So you don't just train the model once on your data set, typically. That would be 1 epoch. But you do multiple times through, because the things it learns along the way can be helpful in understanding the data in more context and learning even better the next time through. Just like if you were studying for a test, right? You read the chapter through once, and then you read it through the second time, and you actually have better context and you can learn better from it. So for number of epochs, I would say 2 to 4 is a really good starting point. I typically lean toward the high end, and because you can always pare it back, and I'll explain why. Another common one is learning rate. The learning rate is how much the model adjusts its weights after analyzing each batch of your training data. So what's happening in fine tuning is that the model is predicting a token, and then it's comparing it to what your completion, your example actually shows. And then it's calculating what's called a training loss, which is essentially how wrong it was. It'd be like if you tried to answer a question to a test, and then you looked at the correct answer, and you're like, oh, well, this is why I was wrong. So, and then you go back and like adjust your knowledge. Well, the model goes back and adjusts all its weights so that it'll answer closer the next time. The learning rate is how much it's going to adjust its weights based on how wrong it was. A common range for this is 0.001 to 0.0004, and it depends on how much training data you have and like which model you're trying to train, but that's a good starting point. And then batch size is essentially how many examples at a time it's going to process before it does an update to its weights. And it's typically just based on the size of your training data set. So OpenAI defaults it to 0.2% of the number of examples in the training set, and they cap it at 256. So then in terms of evaluating your model, the two terms you'll run across are overfit or underfit. Overfitting means that the model actually learned so well from the training data that it essentially memorized the answers and performs poorly on unseen data. So this would be like if you studied for a test and maybe you got a copy of the test and you memorized all the answers and you're like, I'll just memorize the answers and write them out. And then the professor like changed all of the questions and then you did really bad. So because you didn't actually learn the underlying concepts. And then underfitting is that the model did not learn enough from the training data, so it performs poorly on both the training data and unseen data. So that means basically you didn't train it enough, and so you need like more epochs. The solution for ensuring that you're getting a good result is to have validation examples. These are examples that are not included in our training data, and we use them solely to evaluate how the model does on data that it has not seen before. And when we have both training and validation data, we can get this chart. So as the model is doing as the fine tuning is actually happening, it's making this chart and it's recording how wrong it was, the training loss on the training data, and also how wrong it was when it tried to guess validation data. So here you can kind of see that both lines start to go down. That's a good thing because it's getting closer answers and they sort of reach a little plateau. And then the green line, the training loss, keeps going down. So it's getting better at the training data, but then the pink line starts to go up, which means it starts to do poorly on our validation data. So we can kind of see that it's underfit at the beginning, and then it's overfit at the end because it can't do well on our validation data. And then there's a sweet spot in the middle where training loss is pretty low and the validation loss is about the same. And that's about where we'd want to stop our training. All right, so if we have time, I will do a quick live demo, it looks like we do, of entry point. And we will actually fine tune a model here. So let's do it. All right, so this is inside the entry point app. And I'm going to go ahead and create a new project. It's going to be a blank project. It's going to be called the Tweet Sentiment version 2. And I'm going to import a CSV file. So here we have a catalog of some tweets, and then they're classified as positive or negative. So this tweet column is going to be part of the prompt. This sentiment column, positive or negative, is going to be the completion. And we make it a drop-down, basically, predefined options. And then there's a third column in the CSV that we're just going to skip the timestamp. Okay, so we'll go ahead and it's going to ask me how much of the data I want to set aside for that validation data set. I'm going to do 10%, so I'll have 900 training examples and 100 validation examples. Click Finish. And that is going to go ahead and import. And while it's importing, looks like it just finished. But I'll go ahead and show you, I already trained one so that we could see what the result is here. So I have a model I fine-tune on OpenAI, because entry point is essentially a layer on top of other training APIs, so you can compare them, you can run your same data set on different platforms with different hyperparameters and compare them apples to apples. So here in the entry point playground, I'll have a tweet like, I am sad. And we're going to use our fine-tune model. And that has a negative sentiment. and then we're just throwing it easy ones here. But I am happy, positive. It's like we'll give it one harder. I don't know what to think. This is like what? All right, so negative. So to actually create that, we have our examples here that we imported. Bunch of tweets, and we have the sentiment for each one. These are our prompt completion pairs. And we just go to fine tunes, click the plus button. We can choose what platform we want to use, OpenAI, Gradient, Replicate, AI21. We'll stick with OpenAI. We can choose what model we want to use. And then the number of epochs that we learned about. Start with 2 and just press start. Oh, and I should have shown you the cost here. So for 2 epochs, it's 40 cents, right? So, and OpenAI gives you like $5 of free credit. So you can start fine tuning for free. And then you can also modify the template. So there's a lot of benefits to still including a system prompt, especially with smaller data sets, because you can, like we talked about with a chart, you can combine prompt engineering and fine tuning to where you can train the model better at your task, but you can also continue to steer it through the prompts. So we have that ability here. And our data will get shipped off to OpenAI, and it'll be ready in like 20 minutes, but and we'll get a model back like this, where we can see our whole template that it was trained on, and then how it performed as well on our validation data. So the whole point of just showing you a little bit of entry point is that fine-tuning does not have to be that difficult. You do not necessarily have to know Python or configure your own GPUs or anything like that. So I hope you learned something about fine-tuning, and it was great talking to you.
That was brilliant, Mark. Thank you so much. Yeah, loads of great, like detailed information. I think when you've honed in on the why of fine tuning, there was some awesome call outs. Specifically, I feel like I want to share your Venn diagram of Venn diagrams. That was such a great way to show that each one of those approaches is a good way to ground your model and get it to be more accurate. Like it was for improvements, right? Like I love that right in the center. And then I guess it's deciding between the trade-offs of either cost, time, resources, whatever it is, whether you actually get those improved outputs. And then again, calling out that fit versus overfit, underfit piece. That was really nice with the graph. It kind of just obviously showed exactly what point it would work for that model. So yeah, nice call out, and thank you for the demo.
To be honest,
my pleasure.
Yeah, I always thought fine-tuning was a bit of a last resort, right? Where you really don't get the results that you want with prompt engineering, you use fine-tuning.
Yeah.
But then I look at the slide you had with specifically with the prompt that's enormously reduced.
Yeah.
Also from a sustainability perspective, maybe
Yes.
fine-tuning is a better approach in
Yeah.
lots of cases.
I was going to say we had a Green Software Foundation session earlier on, and that was talking about being considerate of the amount of compute and the amount of time and when you train and all of that kind of stuff, and actually choosing the right way to improve your outputs is an interesting one to think about, whether fine-tuning or really large prompts, or even the ordering, like the call out of the ordering. We all know that, but actually when you call it out explicitly and say, well, every time you make a change to that huge prompt, like how do you know even what's about to happen next? Like it's going to get even more complicated, right?
Yeah.
I learned so much.
Yeah, and you made it even more complicated, indeed, for me personally. Yeah, lots of things to
more
think
choices.
about.
That's not what we need. Amazing. Well, thank you so much. It'd be great if you could spend a little bit of time in our AI Discord channel, if possible, just chatting with people, or at least sharing the resources and your fantastic software as well that you're building out, because it looked like a great demo and very easy to use.
Yeah, I'd love to. Thank you so much. Appreciate the opportunity.
Yeah,
Thank you so
always.
much for the great session.
All right, we'll see you later.
Cheers.
Thank you.
Bye-bye.
Okay, with that, we listened to an incredible session all about fine tuning. It took us from being intro beginners to really asking a lot of questions about when, where, how do we fine tune. So with that, we will take a short break to just let our minds settle for a minute, and then we'll come back with a new session.